Hi everyone. Today we are going to talk about a topic which is really important, and that is how to optimize player experience on mobile devices. And this is something which I have been struggling with from a very long time. And if you are building a game for mobile, you know how big of a challenge this is. So to discuss this topic with me is Tommy Krul. He is co-founder of Super Evil Megacorp, chief technology officer, and principal architect of a proprietary game engine. Super Evil Megacorp is known for their debut game Vainglory, which was featured on Apple stage, I think iPhone 6, and then
Uh-huh.
also featured in iPhone X commercial Unleash. So welcome,
hmm
Tommy.
Thank you. Thank you. Thank you for inviting me to have this talk.
Yeah. And Tommy is also advisor in Lila Games, and we have been having multiple discussions on the same topic. So directly jumping on the topic, what are the key issues of getting a good performance and good visual fidelity on mobile devices which you watch from the start, like FPS, poly budget? What are those things which you look into from the start of the development?
Well, so let me first talk a little bit about why the problem is actually complicated.
Right.
Um, Especially if you come from console gaming, which is where I came from. Before starting Super Evil Megacorp, I worked at a company called Guerrilla Games on Killzone, another game they made, Horizon Zero Dawn. Probably some people are familiar with it, and I was on the technology team there. I was also for a brief stint at Riot Games and worked on League of Legends. So, but the majority of my background is actually in console games. And in console games, you have a very fixed platform that you're optimizing for. You know exactly what the hardware is going to be. You know exactly how fast it's going to run, how hard you're going to push it, exactly what type of shader complexity you can run. And so when you move to mobile development, and most people probably listen to this podcast would know that not all of that goes out of the door. You basically have no real point of reference anymore. And it's a little bit back to the days of PC game development, if any one of you worked on that, where, especially for a Windows game, you can have any CPU, any GPU, any monitor, all the way from really low-end CPUs to very high-end CPUs and GPUs. And I think the problem on mobile is actually even worse. Not only because there's a an even vaster range of performance characteristics from one phone to another. There's also a lot of additional elements that actually affect performance. So um, you have different territories, different countries that just, where the majority of phones are different categories of phones. Southeast Asia is known to have a lot more lower end devices, for example.
Right.
And yet they are a vast, very large part of your likely player base. So that is important to support. Some countries bias very heavily to certain brands, right? If your game needs to come out in China, there are certain phones that are mostly only used in China that are incredibly popular there that you might not have access to here. And then even if you have all the right devices, different devices have very different trade-offs in terms of what the hardware is capable of. So some manufacturers, they will put extremely high resolution displays, like very high DPI, on a phone, because you can print on the box like, hey, this phone has this many, this high a DPI, or like,
Right.
twice as sharp as an iPhone. And there's Androids out there that have much higher fidelity displays
Mm.
than maybe your current like top of the line iPhone.
Right.
But at the same time, like that is not always tied to hardware that is equally powerful, right? So you have a very high end display, but a very low end CPU and GPU. And that combination of elements is actually extremely complicated to optimize for.
Right. Right.
And lastly, and this is actually something that only recently I realized. It's not just the combination of hardware,
Mhm.
also actually the country where you deploy sometimes has an effect. So the same device in two different countries, for example, if the climate is incredibly different, right? If you have a phone, if you have a user who is in the tropics or a country where it's incredibly hot, that phone will be thermally throttled all the time.
Right.
Whereas if you're in a country with like a mild climate, this is not a problem.
Wow. Yeah, I think this is something which many people don't think of. Like personally, when we target a device, we always look at the configuration of those devices, but not the geography. Like, the thing you said, thermal condition
Exactly.
of a country, that's very unique. Uh,
Yeah.
so this brings me to the next question, which is now that you have so many devices, and I think the difference between console and mobile is the variety of devices you have. So in iOS that is still limited, but in Android you have like thousands of devices.
Yeah.
So when you are just starting the development, how do you plan like which device to target, and like where do you set the base criteria?
It is a hard problem. It's a hard problem. Personally, for us, I do use iOS as my default SKU, and I think different studios have different approaches for this. I use iOS as our reference SKU
Right.
because it is more stable, because I have fewer number of devices that I'm optimizing towards. I can sort of categorize it. I can say, okay, an iPhone 6 class phone is my low spec, when a iPhone 12 maybe is my high spec. And I can use that as a reference frame, and it means basically the same to any team in the world, to any other engineer. I can just tell them, go and get this phone and use this as your min spec, go that phone as your high spec. I like to do that, and I think that's convenient. Other studios will argue like, well, Android most likely is going to be a much larger part of your install base.
Yeah.
And when it's a larger part of your install base, maybe that is what you should be using as a reference. Mm-hmm. For me, the complexity with that is because there is so little consistency from one device to another, mm-hmm. I find it very hard to use these as reference devices. And it just makes it hard to optimize for it.
Yeah. Then in that case, how do you like, do you plan for Android later on, or do you like, set, for example, if you're just starting your development right now and your game is going to come out in a year, so do you choose a decent device of today that tomorrow, after a year, maybe this will be a low-end device, or do you start with low-end device today itself?
That's also a really good question. We did different things for different games. So in Vainglory, I think we weren't as strategic around that. What we ended up doing for Vainglory was, we build and optimize the game initially for iPad, then for iPhone, and then we operated the game as an iPhone exclusive for a while before we started porting to Android. I think even though we intellectually knew that Android was going to be a very large part, a very important part of our user base, I don't think we gave it enough thought early on in the process. So for our current game, so we currently work on a game called Catalyst Black, which shares a lot of like similar aspects to Vainglory. It shares the same characters or same camera, same perspective, basically same type of gameplay. It's a bit more action oriented, a bit easier to get into, but it's still a similar game experience. And what we did here, and I'm actually quite happy at how that worked out, is that very early on in the development cycle, we looked at the top 100 most popular devices for gaming. Oh. And we ended up categorizing these devices in like sort of like performance buckets, right? So that we had a good representative set of devices in our low end, in our mid end, maybe our high end, and our ultra high end. And we use these devices as our call it, reference devices for QA, for performance testing, for all these things.
Right. So one thing also stands out about you guys is you, instead of choosing any third-party engine like Unreal or Unity, and there are like lots of discussions going around which one is better for mobile, which one is like better for console, but you just wrote your own engine. So what was the reasoning behind it, or did you evaluate those engines and then made a call?
Yeah, it is a question I get asked very often, and I think the true nucleus of the answer is really that I did it because I could and I wanted to. And if you're going to start your own company and go through all the trouble of all the blood, sweat, and tears, why don't you just do the thing that you're passionate about? In my case, my core skill is writing game engines, right? So, and I had been writing game engines, and I had wrote the game engine that we actually ended up using for the company even before we started the company, right? So I didn't write the game engine as part of the company. It was basically a project that I had in development for a while, and that I decided to sort of bring into the company. But I do think that there are good reasons to write your engine. It's definitely not something that I think is right for every team or every engineer, but there are some good reasons for it. One of them, which at least apply to our case, is that if you think back, when we started Vainglory, the industry looked very, very different. I don't even think that Unreal was available on mobile.
Yeah.
Unity was there, but was pretty immature. Unity has made great strides in the last couple of years. But when Vainglory came out, it wasn't a very mature product yet. It was getting there, but there were a lot of issues. And really the industry at large, I like to joke, and I'm not sure that it's 100% true, but like it's almost true. Most of the games that were out, but when Vainglory came out, were match-3 games. Like they were casual 2D games, puzzlers, that kind of stuff. And you could do that stuff perfectly well on Unity. But if you wanted to truly push the envelope, you had to go to a custom engine. And our engine was written, with all the sort of best practices of console engines in mind. All the types of optimizations, all the features that you would think of, multi-core ready. We were also one of the first engines to be fully ported to Metal when Apple came out with a Metal API. When we did the demonstration of that on stage for Apple, Unity still had, they had a beta or like even alpha release of Unity that you could download if you were a particular developer that you could use to port your game to Metal. But it was very basic and it was very unstable and it was not a good product yet. Yeah. We could do that. We could adapt ourselves to any sort of new device that would come out, CPU that come out, maybe a new keyboard, a new input mechanism on your phone, or a new graphics API, and immediately adapt to it.
Right.
And that for us, made a huge change. It made a huge difference. It's also easy to forget, but when Vainglory came out, it was a fully 3D, high visual polish game running 60 frames per second on an iPhone 4.
Right.
Like that, and I have a lot of pride in that we were able to pull that off. And that came from a perspective of really being able to optimize at the very lowest level for what these phones were capable of doing. And we were running maybe 50 animated characters, a large map, all unique textures over the map, right. Hundreds and hundreds of particle effects. And at least at the time, for that generation of devices, if you wanted to pull that off, not only was your only option Unity, I don't believe that at that time you could have built that game on Unity in the way that we were able to. Yeah. And so, though it's definitely not something that is right for every team, if you have technology that makes a difference, or you have an idea that you can execute well on an existing engine, I think that there can be a great value into right. building it for yourself.
Yeah, I think you brought up a very important point, which is it was the context at which you decided to make an engine. So, yeah. I remember those days when I played Vainglory for first time, it was just wow. And then, as a developer, you always wonder how did you achieve that, because at that point of time, I remember it was like Coco Studio for 2D games, and then Unity was still pretty new. People would write their own OpenGL libraries on top of some existing engine to just get something out of it. So that's why Vainglory kind of changed the perception that, hey, you can achieve this quality on mobile device. So that
Yeah.
if you wanted that, if you wanted to execute that vision, you didn't have any other tools but writing your own. So when you are building a game, building game itself is quite complicated. You have to operate so many things. Now that you are building an engine, so this is specifically for people who want to build something on their own, they want to write your own tool. How do you manage the development cycle? Like, did you first complete your engine, or did you made only the parts which were required for a particular feature of that game, and then the parallel development kind of thing?
Um, Also a really good question, actually. It's a little bit of both. So what ended up happening is I had written different parts of a game engine multiple times over my career. Usually I would write something at work, not quite happy with how it worked out because, timelines, constraints, other technology, other libraries that we had to use at the studio. And I would go home and I would go like, now that I've seen A to Z how this system works, if I would redo it from scratch, I would change. I would keep this because that worked really well. I would change this. I would change this. I would change this, and I would work so much better. And that is to this day how I still work. I actually think that it's a good recommendation for any engineer. Build something once and then build it again and build it again. And only the third time that you build it will it actually be any good. Because sometimes you need to build the system in order to understand what you don't understand yet about building the system. But in this case, I had written, call it all the core components of a game engine. And actually what had happened, I had written most, I want to say most, I'd call it like 50% of a basic game engine at some point in my career. And that was the moment I decided to quit my job. And I basically spent a year full time writing another 30% of the game engine. So that after that year, this was unfunded before we had a company. But after that year, I felt I had 80% of a game engine. And that was basically the moment where I probably thought at the time it was 100% of a game engine, but it really wasn't. But it was close enough that I felt confident to start a company at that point.
Right.
And the rest of the game engine was kind of written as needed. Mm-hmm. So, but I got it to the point where you could make a basic game with it before we started the studio. And I think that was the right thing to do. Like, it's very rare that you have the luxury to, while you're paying everyone a salary and while you are sort of like on the clock for producing a product, if at that point you're still writing major parts of a game engine, you are probably in a, you're in a problem. You have a problem because, right. This stuff takes time.
Yeah.
But in our case, I had done most of the game engine before we started the company. But the reality is also like I don't think you can write a full game engine without writing a game. That last, like I say that I got to the 80% mark, but it probably felt like it was the 100% mark because you don't know what that last 20% is until you start building something with it. Right. And clearly now it's many years later and there's still parts of the game engine that we're writing simply because you uncover more and more systems that you would like to have. Okay. The other thing that I think did right was we did choose the game and the game mechanics to fit the technology that we had, right? So if we had decided to make a game that had tons of cinematics, in-game cinematics, we did never have the game engine to do that. Like even to this day, we don't have the infrastructure to build incredibly, elaborate in-game cinematics. But that's fine. The games that we're making don't require them.
Yeah.
So when you use a proprietary game engine, you optimize towards the specifics of the problem you're trying to solve.
Right.
And I think actually, like to bring it back to sort of optimizing for mobile game development, it's the same thing. You optimize towards the specifics of the game that you're building on.
Right.
And this is definitely the case when you have a proprietary game engine, because you can go so low and you can go so deep into the specifics of what you're optimizing for. But even when you're using a Unity or Unreal, you will want to be very strategic with what you're optimizing for.
Right.
And depending on the game that you're making, the content that you're producing, the type of optimizations you end up doing are very, very different, right? If you have a 2D platformer,
yeah,
like that is a very different set of optimizations to worry about than if you have a first person 3D shooter game.
Right.
You know,
That's very interesting because there is a fine line between engineering and over engineering. And building a game engine itself is so challenging that you can over engineer lots of stuff. And the definition of game engine is like, do you want to write audio engine right now, or you will write it when you need it? So that's why,
yeah,
what made sense while you were talking about it is like you are building game engine for a game. So
yeah.
imagine if you didn't have a game and you were just building game engine, then you don't have a milestone what to
Right.
build
Which
now.
is, and the thing is, like, building a game engine as a hobby project, I highly
Yeah.
recommend it to anyone on this call or is listening to this. It is a fun exercise. Like, I think it is a great, way to hone your skill, but it's also a project that can go on for years, decades. And many people that have written a game engine, they've been working on it for 10 plus years.
Mhm.
And as long as you're not forced, like being forced into a product is kind of like a mixed blessing. It
Correct.
is frustrating because you have to take shortcuts and you have to finish certain parts, and you can't write that ultimate system that maybe you're dreaming of.
Mhm.
But it's also a forcing function to force you to finish certain things and to force you to solve certain problems, even if it's not the ideal solution. And therefore, like, I think in our case, like, our engine is a mixture of both. There are systems that I wrote maybe 10 years ago now that I had the time for to truly build an incredibly elaborate system that is very sophisticated, that is very advanced, that that I don't think any other mobile game engines, including Unity and Unreal, do. And we can use those in our pipeline and in the types of games that we make.
Right.
But there's other parts of our game engine that are incredibly basic, and they're kind of basic for a reason. Namely, we don't need anything that is more sophisticated. And actually, building something more sophisticated would cost more time to build it, also more complex to maintain. And the other thing that many people don't realize about complex systems is that if the requirements change for that very complicated system, adapting that complicated system is harder than if it's a simple system.
Right.
And so sometimes trying to write this perfect, complicated solution that tries to cover all your bases, the solution that tries to cover all your bases often doesn't cover all the bases. And therefore, like, if a new basis is introduced that you didn't think of, even though you thought you had, you're in a much bigger problem. Whereas maybe if it's like a throwaway simple script that automated like a couple of steps, you can just rewrite it, start again, add that constraint, write a new system, maybe completely different approach to doing it.
Correct.
Yeah, and we have many examples of that. So for example, Vainglory really didn't have a collision system. We didn't need it. There is no collision in the game. Like, it's all like RTS like event-based collision. You select an enemy and you shoot a projectile to that enemy, and there's a timing issue involved. But like, there is the if it's a targeted ability, the ability is always going to hit.
Right.
So maybe the user has 2 seconds or like half a second to bring up a shield, but they can't walk away to avoid the bullet.
Right.
And in the cases where we did have projectiles, we did very simple, just like very simple system, which we called the physics system, but it was really just a flat array of colliders and a flat array of projectiles, and every tick you just like intersect n times n every single interaction, because at any given moment there is maybe 10 projectiles and 10 colliders, and that's it.
Right.
So you can write something incredibly simple.
Yeah.
For Catalyst Black, which is much more of a shooter game,
Mhm.
we have upwards of 30, 40 characters on screen,
Mhm.
all of which have the ability to shoot at a very high, maybe 10 bullets per second. So at any given and very large maps. So at any given moment, there is a very large number of projectiles on screen, and we needed a dedicated physics system. And even there, we ended up writing a physics system that is not what, for example, would come out of Unity or Unreal, where your go-to solution may be to say like, okay, well, I'm just going to make physics halls, I'm going to put it in the physics world, and I'm going to use either Bullet or built-in physics for one of these engines, and I'm just going to simulate that in 3D. In our case, for example, we could make 2D approximations of all our projectiles and colliders, because the gameplay is essentially being emulated on a 2D surface. So, those calculations were all of a sudden infinitely faster to do, and we could all like parallelize them, and there's a lot of specific optimizations we could make because we knew the type of game we were making. It is not the physics system that solves every physics problem in the world. I cannot stack two blocks onto one another. But boy, can I run a lot of like bullet intersections.
Mhm. Yeah, that's a true agile way of approaching development. So I had another question, which is if you are building for mobile, you have to make sure your game is performant, and you are taking care of performance at all the stages of development. But when do you start looking at performance? Like, you are just starting development, are you always critical about what systems you are writing, or would that be overkill in the start? Or you plan like, hey, let's get all these features done, and then we'll do iteration on performance or something like that?
Yeah, I think it's a little bit of both. I think it's always good to engineer with performance in mind.
Mhm.
So never make decisions that will later prevent you from common sense, good practice optimizations. And the trick there is in knowing how those systems need to work, right? So if you write a collision system because you are writing a shooter game,
Mhm.
it is important that at the beginning you know how other games have solved this and have solved this efficiently.
Yeah.
And that if you know that most likely later you need to optimize it, you write that system such that it is easily optimizable later. If you don't add interactions to it or interfaces to it that will later prevent you from making the optimizations that you do. But given that you're not doing dumb shit early on that gets you in trouble later, I would say first get to the point where you have the game by and large that you want to make. Don't make it pretty, make it playable, make it run. Use a couple of simple devices as your reference point. So in our case, Vainglory was I think iPhone 4 min spec and iPhone 6 high spec. It might even have been that early days we ran on it was like an iPhone 3GS or something like that. Like,
3DS, yeah.
yeah. So have your, and in my case, I use iOS for that because it's nice and stable, and I know what to expect. I know what CPUs are in there, what GPUs in there, what memory is in there. But I would take sort of like a low bar and a high bar, and make sure that you know that those are reasonable expectations. And get yourself to a playable prototype that you can prove out the idea that you have, because your game is most likely going to change substantially through its development cycle. Spending a ton of time optimizing in that very early phase is not useful. But once you start creating content, you need to do this, A, with a very deep understanding of what this content should be. You know, how are you making your particle systems? Or are your artists creating particle systems with incredibly complicated shaders on them, or with extremely high, polygon budgets? Are they making 3D models with single model 100,000 polygons, right? Probably not a good idea. And once you start creating your content, be sure that you know your budgets, even if they are like ballpark budgets. How you know your budget is also a bit of it's a great question. I think, it comes with experience. It comes with understanding and knowing reference games that have done similar things as you. It comes with knowing your technology, which, I mean, in my case, I happen to know because I wrote it, but, it might be harder with Unity or Unreal. In that case, it might just come from your experience writing other games in Unity on Unreal, kind of like knowing where the bottlenecks are. And then, I mean, in our case, what we ended up doing, for Catalyst Black, we did that. Catalyst Black was quite different. So our current game is quite different from Vainglory, where Vainglory looked very pretty, but everything was baked out early on. And I did this very specifically because we were dealing with iPhone 3GS and iPhone 4, which are fairly underpowered devices. Actually, the worst offender at the time was the iPad 3. The iPad 3 was barely any faster than an iPad 2, but because it had a Retina display, it had 4 times the pixels. And so it was a horrendous device to optimize for. It was very, very hard because it just, we had to, I think, average out like 1 or 2 cycles per fragment, per pixel that you're rendering. And anything over that would just, it would just, we would no longer be able to run 60 FPS. The interesting thing is actually, if you look at, if you have an old iPad 3 lying around, you'll notice that even in the operating system, if you're just browsing it, Apple, in some cases, can make the device run 60 FPS as well. Their internal teams had similar problems getting the frame rate up to par because it was such a mismatch of GPU and display. For Catalyst Black, we went the other way. For Catalyst Black, rather than having everything pre-baked, which works really well because everything is fast and you can make really pretty graphics, right? Like your graphics are as pretty as you can just bake them. The big downside is that it's incredibly complicated from a authoring point of view. We had tremendous trouble building new levels and building new game modes because everything was so static. It was the amount of effort, and I really give credit to the artists working on it, like the amount of effort to build a pretty level, although it was very pretty at the end, it was a vast amount of work, like many months of work just to build a new level because everything had to be flattened, everything had to be merged together. We would merge all the geometry of the level together in like big blocks. So like it wasn't like a tree and a model of a tree and a model of a fence or a rock. It was like big blocks of like maybe 20 or 30 by 30 meters. That was a single mesh with everything baked in there: the ground, the walls, the cliffs, the vegetation, a single mesh, and single draw call. For Catalyst Black, we're making, because authoring new levels and authoring new game modes is a very important part of the gameplay experience. We ended up doing a lot of real-time techniques, lots of real-time shadows, real-time dynamic ambient occlusion, real-time lighting, real-time reflections, fairly high-end stuff. And of course, that stuff is way harder to optimize. And I give credit to, we have a extremely talented graphics engineer that joined the team last year. And when we brought up our Android port, although we've made builds and made sure it wasn't horrible, we had mostly tested on like mid to higher end devices. And even the mid devices, when we ran the game the first time, we were running at like 15 frames per second. And we had to go through a lot of optimization to get that to the expected 60 FPS. And then we had a category of like low-end devices that were truly running like 3 to 5 frames per second, that we had to get up to at least a acceptable 30 FPS or 25 FPS. And there was a tremendous amount of effort to do that.
Yeah.
So in this case, actually, our Android performance, we did fairly late in this case. Also because we were still building a lot of these real-time technologies, so real-time lighting, real-time shadowing, real-time reflection, ambient occlusion. All these things came online somewhat later in the life cycle of the game.
Okay.
For a long time, we were basically just using the Vainglory pipeline, but without any of the pre-baking, which meant that the game just didn't look very pretty because the lighting was very basic.
Yeah.
And so we started, in this case, optimizing the Android build fairly late. But, and this comes back to the point I was making earlier, we made absolutely sure that we didn't do anything obviously stupid. So everything that we had implemented earlier, even though we maybe had not made the optimizations yet, we knew what the optimizations would be. And at least within a certain error bar, I was pretty confident that we would be able to get it up there.
Yeah.
And then there's always the mother of all optimizations, which is just to like, crank down the resolution of your screen, which, is a very coarse tool that you have, but it works incredibly effectively.
Right.
So, luckily we didn't have to do much of that, but that was sort of my fallback. Like if everything goes to shit, I would be able to reduce the resolution of our game and at least make the game run on lower end devices.
Yeah.
At an okay frame rate.
Right. I mean, there is no one solution, for every problem, and these are something which you do, and then what works best for your game. So that's why there are so many. It's like really pretty challenging problem to solve. So this brings me to the next question, that is, how do you QA and test against performance? So like there are so many devices. There are iOS devices, Android devices. Then as you also mentioned that in the start you were only testing against your mid-level or higher end devices. But at some point you have to switch to the devices where you can support your game. And now you have a list of 50 devices where you want your game to work. So like do you like manually test those, or do you automate some of those tests? Like how do you approach this?
We don't automate it. What we ended up doing is actually we had so I already said that we ended up finding sort of the list of 100 most common devices.
Yeah.
We ended up paring that down to, I think, 14 or 15 devices that spanned the spectrum, that spanned all the different CPU and GPU combinations that we were aware of, and also that kind of covered the performance spectrum. And the first phase of our optimization pass was literally those devices. We put them in a Excel sheet. I think horizontally and vertically, we had a couple of locations within the game. And then for each location within the game, we had the build number. And we would just QA. I would just ask our QA guy, like, okay, build the game, this build revision number for these 15 devices. Tell me what the frames per second is on this location of the map, this location of the map, this location of the map. And then we would make some changes and we would do it for the next build. And that is, like some devices at that point were already running 60 FPS, some were like 30 FPS, some were like 15 FPS. And at that point, we started optimizing it such that we got that whole set of 15 devices to our, I wouldn't say we didn't get them into a great place, but we got them into an acceptable place. And at that point, we made the pretty uncomfortable decision to go live with this build in our public beta. So basically, we brought in our Android players. At this point, the beta had only been out. We're still in beta, by the way, on Catalyst Black. But at this point in the development cycle, we had been out in beta for iOS for a while, but not on Android. And it was at this point when we got those 15 devices to an acceptable level that we brought in our Android players. And of course, immediately what happened is a whole ton of devices didn't work. We found many more that were performing poorly. And then it was a combination of just listening to our player base. And the moment that we identified a device as particularly problematic, either because it was crashing or because the performance was bad, we would buy that device and just add them to our testing pool. The other thing that is kind of interesting that we did is we instrumented the game right before this build went live, because I did not expect those 15 devices to truly cover,
Yeah.
Android. I mean, like, of course, I hoped and prayed that, the game would go out and it would work well enough. But of course, that it's never how that works out. So before the build went out, what we ended up doing is we instrumented the build, which means that we collect, I think we do different things and we can control it remote. So in different phases of the project, we have had it in separate setting or different settings, but like some percentage of our player base, every maybe 30 seconds, we capture 4 or 5 seconds of FPS data, including the min, the max, the medium, the variance. We also grab the amount of memory that is being used on the CPU, amount of memory that's being used on the GPU. We get the GPU model, we get the CPU model, we get the number of cores. If possible, we get the temperature that the phone is running on, like a whole bunch of things. And for this percentage of people, we use essentially an A/B test for this, so that a certain group of players is in this profiling group and another group of players, we don't collect these data. And of course, everything is anonymized. We submit that to our analytics system, and we track this for a certain percentage of our player base. And with that, we can then run analysis on all of that and see what we are doing.
Correct.
And there were some really interesting insights from that. So for example, I completely missed the whole category of GPUs in all our testing. And I think maybe this was just because we were biased looking at Western games when we made when we selected our test devices. But there's a small number of the Android devices that use Power VR GPUs. And although in theory I knew that because almost everything is Mali and Andrino, like in my experience, that is basically 100% of the market. But it really isn't, depending on the country that you're looking at.
Right.
And we had some countries where we had a very significant percentage of users on some combination of hardware that included Android Power VR. And those Power VR users, basically the game was always crashing. So initially the problem was like, why? Actually, we noticed that none of our Power VR users, when we plotted our retention against our performance and install base, we saw that we had a big group of people on Power VR that were 0% retaining. And either running very, very low frame rate or,
right,
probably just immediately crashing. And this came out of our analytics data because I just had never accounted for Power VR hardware in any of our QA, but also in none of our profiling. Even once we got it to not crash, it was still performing incredibly bad because we had not defined any sort of default settings for this combination of hardware, and therefore it would like just pick some random arbitrary mid-setting default that really did not fit a lot of those phones.
Right. Yeah. I think two important points which you discussed with me last time when we were actually discussing the same topic. One was what you guys have done is you have list of devices and you have categorized them in a group, and then you have configurations which you download on the device. So if since it's single binary running on multiple platforms, how do you control, like, this is the ideal setting for this group of device? So that's just one thing I wanted to add in this conversation. This could be useful for people. It's like, group your devices, have configurations, and then on the load of the game, first load, you can just pull that perfect combination for that particular hardware.
So I mean, you can do that, and this is, I guess, highly dependent on like what engine you use or what technology you use.
Right.
In our case, all our content is converted in a way. So we actually don't pull down specific content for specific configurations.
Mm-hmm.
All the one binary runs on all the way from like the lowest end to the highest end.
Mm-hmm.
There's some benefits to that. There's also obvious downsides to that, right? If you are of a very low end phone, there's no need to download all the high res textures.
Right.
And we've definitely thought about, and I would still consider in the future, basically having a high-end patch that patches assets with their highest end settings for certain devices, so that everyone downloads the same basic binary, and some high-end devices pull down an additional set of assets that has higher resolution textures, maybe higher quality sounds, higher quality video. And you can even make this optional, right? If someone doesn't have a whole lot of storage on their phone, you can ask whether or not they actually want this. In our case, the way it currently works is we have all these different configurations, and we have a configuration file that we ship with the build, but the content is the same. We are just able to tune the content in different ways with either shader LEDs, which that is a big part of the performance, of course, right? Like and this is very easy to mess up on an off-the-shelf engine, because every feature that you have is so accessible, right? If I want to write, I don't know, a post effect that is depth of field. So, you can focus your camera on something, and something that's very far away is out of focus. Our game engine currently doesn't do that. We could add it. We don't need it because, we have a top-down game. But this would be a deliberate choice for us to add it. And in that deliberate choice, we would deliberately think about the performance implications of adding that feature. If, on the other hand, you are an off-the-shelf engine, all of this is built in. So your artist just goes in, or even you go in and go like, oh, this looks really great. Turn this feature on. Oh, it looks really great with like 6 dynamic lights. Turn all the 6 dynamic lights on. This level looks so much better with ambient occlusion, full screen ambient occlusion. Turn ambient occlusion on. And before you know it, you have an incredibly expensive game that looks beautiful, but also you've never had to truly think about the implications of how you're gonna make this whole thing perform, right? And how you're gonna pull off all these visual effects together, and how they work together and how they will work performantly. In our case, we can generate different shader LEDs, automatically generate shader LEDs. So we start with a graph description of a surface, of a shader. And in our convert process, we can build different shader variants from that basic ideal shader. And in that convert process, we can say like, okay, well, actually, on low-end devices, rather than 3 dynamic lights, actually, you're only going to take 1 dynamic light into account. Right. If for certain category of objects, if your specular texture has very little detail in it, we can analyze the texture, come to the conclusion that there's almost no detail. Then for your low bitmap, just leave the specular texture out there, or just assume that it's black, right? And skip the calculation. Right. So we can tear down, or maybe on low end we say like, you know what? Don't do any normal map calculations. Doesn't look as good, but it may be fine, right? Like if you run a 7-year-old phone, especially if this is a rock that is just a prop in the level, who cares that it has normal maps? You're just running past it.
Right. Yeah.
And so we can automatically generate different shader LEDs, and that's one way we're tuning in the performance. And with this configuration file, we can just categorize our devices and say like, okay, well, this type of device falls in this LED category. Other things we do is we switch certain things on and off, not just in terms of shaders, but also in terms of full screen effects, in terms of what resolution we render at, how we composite things, what full screen post-processing we run. All of these things we can sort of tune depending on the bucket. Correct. Now, this way of tuning performance for us works well enough. I definitely don't think that this is the gold standard of performance, because coming back to what we discussed earlier, especially on Android, it is incredibly hard to bucket different devices. So most studios, including us, we end up bucketing by GPU or by GPU and CPU combination. Um, Actually, the worst that you can do is to bucket based on phone model, because I mean, some of it you guys will be aware of that, but even the same model on Android, the same model phone, will be able to come in many different hardware configurations, sometimes completely different brands of GPUs. On the phone that has the exact same name, you might walk into the store, you might buy a particular phone, and you might go home, and your phone might have a Mali CPU, GPU rather than an Adreno,
Mm.
and you wouldn't know, even by the serial number, you wouldn't know.
Correct.
And this is, of course, extremely hard to do. So rather than bucket based on phone model, most people would bucket based on GPU or GPU and CPU combination. But even that is tricky because, we, for example, talked about, if you live in an extremely warm climate, that phone will be thermally throttled 100% of the time.
Yeah.
And when a phone is thermally throttled, it's running at 40% power or 60% power, right? So if you make your game run 60 FPS and now it's running on 60% of the power, now all of a sudden it runs like 35 FPS or 40 FPS, it's a huge drop. Or worse, it goes back and forth, right? The player starts playing, has a ton of fun, runs 60 FPS. 10 minutes later, it's running at 40 FPS.
Correct.
Um, so I don't think that there is a gold standard of how to do this. Some sort of dynamic bucketing, I think, would be even better, right? Like if you can keep track of your performance characteristics of your game and dynamically sort of reclassify. Maybe you start with the default, but if your performance is not up to it, you could sort of like essentially degrade the performance settings over time.
Right.
Depending on whether the phone is running particularly poorly. We would definitely consider doing something like that, and there's definitely cases where something like that would help a lot. Another thing to just do is just expose the quality settings, right? Like it's basically back to the PC days where when you had a game, the first thing you would do is you go into the settings menu and you tune the settings of your game to your particular PC. And especially on Android, that is still something that might be good because uh, some devices might require that because it's just very hard to exactly pinpoint correctly where they fall on the performance spectrum. And also some users just have different preference, right? Some users will say like, oh, I want my game to be really pretty, and I'm okay if it runs 45, 50 FPS, as long as I have all the reflections and all the shadows. But the other player is like, hey, I'm competitive. I turn everything off. I just want a straight 60 FPS. I never want my phone to get too hot so that I can conveniently play it anymore. I'm okay switching all the features off, just make it run really, really fast. So different players also sometimes have different preferences.
Yeah, I think it comes down to like how much can you do, and some of these optimizations you can do after the game is live. So now you know
Yeah.
that these are the this is the user base, and now I will just take this bucket of users, try to improve performance for them through this dynamic configuration,
Yeah.
and then you can keep doing that. Keep bucketing your live players.
Yeah.
So like people who are listening to this, they might think like, hey man, this is so challenging. Like, there are so many attributes and so many scenarios for performance optimization on mobile. And that is true. But it's like, be agile, like, build the game, test it, and then know your audience, know your players, because there might be 100 standards in the market, but those might not be relevant for your game and the type of game you are building. So really useful insights, Tommy, which you shared. So this brings me to the last question, which is actually not related to this topic, like performance optimization, but this also comes from your experience of building a studio from scratch. So like,
Mm-hmm.
you came up with an idea of a game, and then now you are assembling a team, and then you start working on the game. So what advice do you have for companies, or even within the companies, when they are setting up a new team for a game? What learnings did you have while building this team from scratch for this game?
Oh man, like where do I start? Um, so many. So many.
Or maybe the most critical mistakes which people can avoid. So that could be a.
Um, okay, let me just go over a couple of them. What would I tell myself, my previous self? Um, a common Silicon Valley wisdom, which I now will truly understand, is you will need more time and more money than you think when you start this project. So whatever amount you raise and whatever amount of time you've given yourself, even when you padded it, is not enough. It's just not enough. And you're going to face that problem, and you will have to deal with that problem. I remember, I think that we were actually lucky in this regard. It's a funny anecdote. When we raised our first round for Super Evil, we went out to raise $750,000, and we thought we could get the game done in 8 months. And our first investor, being infinitely more seasoned than we are, was like, came to us, and he was like, don't take, just because it was from him that we were raising the $750,000. He's like, don't take the 750, take $1 million. You will need $1 million minimum. And we thought like, oh, why would we do this? Extra dilution, But he was right, and we needed more than that. Like we ran out of money by the end, and although I think we had a game in beta after a little under a year, which I still think is pretty impressive. We were a very small team, maybe 5 or 6 people at the time, built the game basically from scratch, including the engine, including all the art, all done in-house, no outsourcing. Just through hard, blood, sweat, and tears, hard work, blood, sweat, and tears. But we did have to raise more money. Like we did not have the budget to then launch the game. And we were lucky that, we had a game that we could put in beta and that showed promise and people were liking it. But had the game been further behind, had the game not resonated yet with players, I don't think we could have raised more money and Super Evil would never have existed. So that would be one. You're going to need more time.
Right.
You're going to need more money. And therefore, there's no time to lose. Don't spin your wheels with things that are not important. Like, get to that game that you want to build. Because getting to that point will prove to you all the things that work about the games, but more importantly, all the many, many things that don't work about the game and that you still have to change and fix. And, if you get to the point of discovering the areas of the game or the product or the technology that don't work, by the time you ran out of like 80 or 90% of your money, you have a very big problem. Other learnings. Building teams is hard. Building teams is incredibly hard. Hiring is incredibly hard. There's not just like hiring the right skills, but also hiring the right personalities. Evolving those personalities over time is incredibly hard. The type of people you need early on in a company are very different than the type of people you need at a mid-sized company, and again, different from if you're a larger size company or when you start your second game. This was definitely a very painful phase that we went through not too long ago when we transitioned from Vainglory to Catalyst Black. Like when you do your first game, it's a little bit like the first album that a singer makes, right? You put your heart and soul in it. You know exactly what you're making, right? Like you had all your years of working towards that one game you had in your head. All the founders are aligned around this one particular game, this one vision that you all had. What if you make the game and it's not as fun as you thought it would be? And now you're 3 founders or maybe a team of like 15 people. All these people signed up for that original game that you said was going to be great. And that's the game that they spent their energy on, their passion on. And that's the game they signed up for making. If now you go like, actually, this game didn't work really well. I mean, you guys are working on a shooter game. Right. What happens if you guys are, we tried a shooter game and it doesn't quite work. We're going to make an asynchronous game. Mm-hmm. And like half the team is like, well, I really want to work on shooters. what the fuck, man? I thought we are gonna make shooter games. And maybe you say like, I want to keep making shooter games because that's all the gameplay that we've made. And your business partner is like, but we look at the, the metrics, and the progression part of our game works incredibly well and people are loving it, but the shooter part no one really cares about, and this is not a part of the core mechanic. Like, it turns out that this is not as part as important a part of the experience as we thought it would be. And that misalignment then, like trying to reinvent yourself,
Hmm.
incredibly hard. Um, Other learnings, man, I could go on for a while
Yeah,
if
I
you
mean,
want to.
yeah, this is something like pretty challenging for everyone. But the 2 points which you discussed, those are like real challenges because no matter how uh, close planning you do, and no matter how much you define, break down your problem, but you always miss a target, even a smaller target. Like you plan a sprint for 2 weeks, and most probably you will not finish everything in 2 weeks. So think about a
Yeah,
plan for a year. So that's really a challenge which I can imagine like people facing. And the other one is like hiring. We are facing the same challenge, hiring against culture, hiring against the belief system, because when you are just starting, everyone has to believe in the same mission. So
yeah,
it has to be more than a job for the
yeah,
people whom you are hiring for the
yeah,
first,
for sure.
right? So thank you so much, Tommy. Like, this has been really helpful and lots of things discussed. This is not an easy topic to cover in one podcast, but this definitely gives some idea about like how people can approach this problem and plan for it.
Yeah,
So
I
thank
hope so. I hope it was useful.
right. Thanks for being here, Tommy. Thank you so much.
Yeah, my pleasure.